Okay, so thanks Fabrizio for accepting to volunteer to give us a webinar. For those who doesn't know Fabrizio, he is a professor at of computer science at the University of Southern Denmark. He is also our president of the microservices community, and he is a maintainer of the Jolie software, of which today he will give us an introduction and demo. So I stop here. Thanks, Fabrizio. The floor is yours.
Thank you, Jacopo, and thank you everybody for connecting. So I'm going to start by sharing the only tool that we will see today in this presentation, which is my Visual Studio Code window. Can you all see it?
Yeah.
Very good. So I'm going to use exactly the code from a GitHub repository that I put online and you will have access to. I'm going to show you the link right afterwards. But essentially, everything I will show, you will be able to run again by yourself later. When you will open the repository, Visual Studio Code will ask you whether you want to reopen the folder in a container, which I strongly suggest that you say yes to, so I'm going to do it now. This will start a development container, or dev container for short, which will basically have all the tools that I'm going to use. So you will have exactly the same environment that I'm using here to make the presentation. And so if you look at the README that we have in there, essentially it will tell you where to find this. So I'm also going to post the link in the chat, github.com, fmontesi, my username, intro-smp-jolie. So it is link in the chat now. And essentially, you can find everything in here, as I told you, and I'm using Visual Studio Code. You can also install Jolie manually if you wish to, but that's up to you. All right, getting to the presentation. So this is a small introduction to structured microservice programming. Structured microservice programming essentially is a programming discipline or paradigm, if you like, whereby the key concepts of services are reflected in the structure code. And the Jolie programming language is designed to achieve this, or to guide the developer towards achieving this style. Now, in the repository, you will find the README, which is what I'm displaying here, which tells you how to run it, a few useful links and contact information if you want to reach out to me about anything that I will present or is in the repo. I'm going to start with a very simple example, which is this one. So for every example, I have prepared a diagram of its architecture. One of the most important things about microservice architectures is thinking about how you are going to structure your system into a set of different microservices. These microservices are usually managed by separate teams, might be written in different programming languages, and should really be handled in separate directories or repositories, depending on the software engineering process that you follow. Now, this is not a presentation about that. This is a presentation about how to program them. So I've allowed myself to use a single repository for all the microservices that I'm going to talk about. In this first example, I'm going to show you how to code a very simple greeter service, this one here. So a greeter service is very simple. There's a client and a greeter, and the client asks the greeter for, could you give me a greeting for this name? And then the greeter replies with hello, followed by the name that the client has sent to it. All right, just to get warmed up. So this is the code for the greeter. Now, Jolie is contract first, and now we are getting into the concept behind what you have to deal with when you write a microservice. So first off, you have to think about the API of your microservice. We call it an interface. An interface consists of the names of the operations that you can invoke at the service. In this case, we have a single operation called greet. And this operation takes a greet request and replies with a greet response. So it's a request response operation. And usually we write this explicitly, that you send a request, you get a response back. Okay, There's another type of operation, which I'm not going to talk about today, which is called one-way, where you just get a reply. So it's an where you just get a request. So it's an asynchronous operation. Now, when you define an operation signature like this, or type of the operation, you want to specify the type of the data that you get as input and the type of the data that you reply with. So the type of the data that we expect just contains a node called name. In Jolie, all data is essentially a tree with labeled nodes. So this is a data tree containing a child called name, which is a string, or you can think of it as a dictionary or a map, if you like. And then what we reply with is a greeting, which is a string. All right. So that's the API of our service, or its interface. Now, interfaces, they just live wherever you want in a Jolie module. A module is essentially a file in Jolie, like in Python. And then you can define services that implement interfaces. So when you define a service in Jolie, you have native keyword called service, and you can start defining the behavior of your service. Now, the first thing I have here is called execution concurrent. It means that whenever we get a client request, we are going to deal with concurrently to all the other client requests. So if we get 100 client requests at the same time, we are going to deal with them concurrently. We are not going to make each one of them wait for the next, for the previous one, and so on and so forth. We are going to deal with all of them as soon as we can. Now, the second thing that I'm defining here is an input port. One of the most important things to think about when you design a microservice is its access points, or rather, how is it accessed by the network? A microservice is always accessed by another service through the network. So this is one of the first things that you should think about. And then you have three elements. You have the location, which tells where the service can be accessed. And in this case, we are saying we are going to use TCP/IP sockets at this local host on TCP port 8000. The second element is the protocol. This defines how we are going to transport the data when it goes back and forth between the client and the service. SODEP is a binary protocol, which we choose here for efficiency. But here, for example, you could write HTTP if you wanted to make a web service or a REST service. And then you write the type of, you write the interface that can be accessed through this access point. In this case, the greeter interface that we have defined up there. Once you are done defining the access points, you can define the implementation of your service, which goes in the main code block. And here we have a very simple implementation. We are just implementing the greet operation. The greet operation gets a request. So this is now the name of a variable request. And we are writing also the name of the variable that we are going to use to store the reply or the response, called response, very simply here. And then in curly brackets, you write the implementation of the operation, what happens in between receiving the request and sending the response. So what happens in between in this case is that we create a subnode called greeting inside of the response containing the string that we want, hello plus the name that we have inside of the request. Okay. So by the way, if anything is unclear, please feel free to interrupt, ask questions in the chat, or just raise your hand in the video since I can see you. All right, so to run this, you just get in the right directory. You launch the greeter service using the Jolie application. Then we can launch another terminal, which I'm going to put up here. And I have coded a client, also in Jolie. Coding the client is very similar to coding the service in this case. What I am doing here is that I'm using an import instruction to import the interface or the API definition, if you like, of the greeter. And then I'm writing a service as well to implement our client. Now, it might feel weird to say that I'm writing a service to implement the client, but in Jolie, all components are services. Jolie is a service-oriented language. There are no objects, there are no functions even, there are only services, and we encode everything we need in terms of services. So a client in this paradigm is essentially just a service that does not offer anything to the rest of the system. It just does something. Now, what does our client have here? We have an output port. So this is the dual of an input port. This is not expressing an access point. This is expressing a dependency. So I will reach out to the greeter at this location using this protocol, and I expect this external service to provide this interface, greeter interface. And what is the behavior of the client? It invokes operation greet at the greeter, which you write just like this, greeter at, so greet, sorry, the name of the operation at the service that you expect to provide an implementation of the operation. Here we have the payload of the request that we are sending, which is just a tree containing a single child node called name with the string Alice, and then we store the response in our variable response. So if I run the client from the right directory, run the client, it works, but it doesn't print anything because we have not written anything about printing to screen or showing us any kind of debugging information. But if you run Jolie with the --trace option, Jolie is going to print for you information about each step that the engine is executing for you. And we can see here that we have sent a message containing a name Alice, and after we have sent it, we have received a response containing a greeting, hello, Alice. Now, of course, it is possible to print things on screen in Jolie. So let's get to that. And it is actually quite interesting to see how it's done. So this is now another example where I have a greeter. The greeter is exactly as before. Launch it. But the client is slightly different. The client is almost like before. I have added only 3 lines. First, I'm importing the console symbol from the Jolie standard library. And then I'm using this instruction called embed. Now, embed essentially takes the name of a service as a parameter, in this case, console. So this is a service defined in the standard library. We give it a name, and this is now a name we can access inside of our code. So I ask for a greeting for Alice, just as well as before. And now I'm going to print the greeting that I receive from the service. So if I run this, I'm gonna see a message on screen. Now, why have I said that this is interesting? It is interesting because we are treating console, which runs internally to our client service, in our implementation as if it were an external service. Or rather, we do not distinguish between internal and external services in the implementation of our behavior, of the main block here. Why is that useful? Why does the Jolie programming language give us this feature? Well, it's because you might change your mind later on in your software project. And one of the key features of structured microservice programming, or which the Jolie programming language tries to apply, is that it should be possible to refactor your microservice architecture, because the architecture is essentially the key aspect of a microservice system. So say that one day you decide that you do not want to print the message that you get locally, you want to print it at a remote location. So you have a console somewhere else. Then you change the client in a very simple way. Oops. There it is. So this is my new client. I still import it from the console module, but now I import just the API of the console, the interface. And instead of embedding within my, my service, a console service, so a nested service, I am creating a dependency, an output port, towards an external console service running at port 8001. So now, instead of accessing a local console, I'm accessing a remote console, which you can imagine could be useful for debugging, for example. And how does my code change in the implementation of the service? It doesn't. That's the short answer. So in Jolie, we really strive to keep the code that declares, so declarative code, it's declarative code in the sense that it abstracts a bit from how it is concretely done, but this code defines how we're going to access other services or how other services can access my service, which I'm defining here. But the implementation of the behavior of the service is kept abstracted from that as much as possible. So with that in mind, I'm just going to get to that example. I have now 2 services to launch for my client to work. I have to launch the greeter, which gives me the greetings. And then I have to launch a remote console service, which is going to be available at this port. And then I can launch my client. Here it is. So now the client, which of course doesn't work. The niceties of doing live demos. Let me check what the problem actually is. Name, greeting. Oh, right. I coded a client that gets now the name from the first command line argument. So now I can ask for a message for Alice. And now you can see that the client is not printing anything, right? Because it's accessing a remote console, which is on this other shell now. So it's printing somewhere else. If I run the client again with Bob, I get another greeting printed somewhere else. And this is just an artifact of Visual Studio Code. There's Bob written here. So basically, if I had to depict it, we have changed our architecture from something like this. So we had a client with a local console. So you can see here, I made this square, well, this rectangle to represent the fact that they're running in the same virtual machine, if you like. So the client invokes the greeter and then communicates locally with the console using local memory in this case to print messages locally. But then very easily we have switched to another architecture where we have the client connected to both the greeter and the remote console somewhere else, and we print at that remote location. All right, so one of the first features of Jolie is that it's easy to change where things are located, which is very important. So for example, you can start drafting the implementation. You make a little prototype of a microservice system, and for some reason, maybe you want to code something quickly and run everything inside of the same application. So you can do that, you can start like that, and then Jolie tries to guide you towards making code that then can be transitioned to a remote or a fully distributed architecture. It is not, of course, perfect. There are important differences between local architectures and distributed architectures, like you have to worry about communication faults way more in a distributed architecture. But the deal is that you get this help in keeping the code of the implementation as separate as possible from the structure of all the access points and where things are located. Another feature that you get out of this abstraction is that if we take the greeter again, okay, so this is our greeter, you can go and change how it is accessed without touching the implementation too much, or in most cases even at all, like what I'm going to show now. So if I change our binary protocol from SODET to HTTP, and then you can pass parameters to a protocol. You can say, I want to use XML as data format, and maybe I publish it at port 8080. Then you can just run the service for greeter, right? Now it can be accessed through HTTP. So we can use a standard tool like HTTP PI. which I do here. So all the demonstrations that I run, you can find on the repository. So I'm running the demo from simple HTTP reader. The demos, when you run the scripts, it will guide you step by step. So it will show you the command that it's going to launch, and then you press enter and it executes it, and then you go forward in the demonstration. So for example, now I'm running an HTTP client, which is going to get this address for us. And I get a greeting for Alice in XML. Now I'm asking for a greeting for Bob, and I get a greeting for Bob in XML. You can change it however you like. So for example, maybe you don't like XML, maybe you like JSON a bit more, then you just change it in the code, relaunch the service, and we can launch our demo again. So I'm going to ask for a greeting for Alice, and I get a reply in JSON. I ask for a greeting for Bob, and I get a reply in JSON as well. Now, how is this different from other ways of programming services? Well, in most frameworks, actually, the representation of your data gets mixed in with the code that you're writing for implementing the behavior of the service. So even in most JavaScript frameworks, you're going to have to write that, okay, this data now I need to convert it to XML or to JSON, and you're using, for example, in Java as well, certain classes to represent XML data or JSON data. In Jolie, you get an abstract data format, the one that I'm using here, for example, and then you write separately how it should be encoded or decoded into other formats, so that you can change your mind in the future. You can either use multiple formats at the same time very easily. So if you want both to be able to access the service through HTTP and with the sharded binary protocol, you just create 2 input ports, 2 different TCP ports. One accepts binary messages, the other accepts HTTP messages. No big deal. Depending on the kind of framework or language that you use, this could be a huge deal because maybe this code is mixed in your implementation. Well, the code for doing encoding and decoding, or marshalling and unmarshalling. All right. Now, this is just a taste of a few structures, so access points and implementation. Let's get to something a bit more realistic, just to show you how it is to manipulate the data structures in Jolie. So this is a bit more involved service. It's called users. The architecture is very, very simple. That's just this service for now. Users has 2 operations. One is for getting information about the user. You just ask for information about the username, like Alice or Bob, and then you get back a data structure like this. It contains the username of the user, the name of the user, the email address of the user, and the little thing called karma in this example, which is an integer. And then there's a list operation, which gives back a list of all the users with at least the amount of karma specified in the request. The implementation is very simple. So we have an input port, which I'm going to get to later. So we have the init block. This is basically, you can think of it as the code to run when the service starts. So this code is executed before you accept any invocations from the client. We have a data structure called users. And this operator here is called deep copy. So it copies entirely the data tree that I specify on the right inside of the variable I specify on the left. And it can be recursive. So here I'm creating a tree called users with 3 children, Alice, Bob, and Carol. Alice contains this name, this email, and this karma. So name is Alice Apple, email is alice@julielang.org, and karma 4. And Bob instead has this other data, and Carol has other data specific to Carol. Okay, so I just have this data tree. And now I have the implementation of my operations. I need to use this square bracket to specify that this service accepts invocations on either get user or list users at any time. All right, this is how you express what people call, for example, in CCS or the PyCalculus, an input choice. Now, get user gets request, which contains a username, it checks, is the username defined in my user's data structure? If so, I just get it back. Here I'm using this round parenthesis to access it like a dictionary. So if you're familiar with other languages with dictionaries, this is essentially the same as writing something like this, right? And like an associative array. And then I return it. If I do not find the user, I throw what we call a fault, which you can think about as an exception, essentially. So this is the name of the fault that I throw, and this is the content of the message with the fault. And then we have list users. List users is also pretty simple. We just loop over all the subnodes of the three users. I access each subnode, I store it in variable user, and then I check if the request specifies a minimum karma, then I check that we have at least that karma, and if so, I add it to the reply. The minimum karma is optional. Essentially, this is what the implementation is saying, which is reflected by the type. So here, min karma, I wrote a question mark, which means that a request for list users can have a minimum karma requirement or not. Okay. Now I have skipped the input port because the input port is a bit involved since I'm implementing what people call a REST service. So I'm saying that if you access a path user we're using the get method, then this translates to a call to list users. And if you access instead the path /user/ and then a specific username, this translates to a request for operation get user. And this username will become a child of the request that we see in that operation. So this is essentially how you make a REST service in Jolie. If we run it, then we can run our demonstration. Like this. So now I'm going to get user Carol, which is inside of our data structure. So we should get something, and I get information about Carol. I see it has karma 3. And now I invoke user by putting minimum karma as a requirement from the query string. I want the list of all users with at least karma 4, and I get that. All right. So going forward, you will find in the repository some more, I mean, this is basically with a data structure that I put as a constant in the code. In the real world, you will want to have a database. So I also put a couple of examples of how you do this with a database and how you set it up, essentially. So if we go now to this other example, this is exactly the same. But I made an implementation of users that uses a database powered by HyperSQL. It's a Java SQL engine, and it works very similarly to the service that I have just shown you. So the API is the same. I have added an operation for creating users. Now that we have a database, we can create them as well. The input port is the same, but for the addition of an operation for creating users, which requires HTTP method post. And then there are extra bits for connecting to the database. So Jolie has a standard library service for connecting to databases called the database. You just invoke the connect method with the right parameters, and you get connected to the database. And then I replaced the implementation of each operation by using SQL queries or insert statements. Jolie gives you a way of protecting your service from SQL injection, which I really recommend you use. So you specify your SQL query, but then instead of putting the values as hard-coded, instead of adding them manually to the string, you can use these named parameters like username, and then you pass as children of the tree that you pass in the request, like this. You pass these parameters. And here I'm just getting them from the request that I got from the client. So it's essentially the same, but with a database now. And if we run this, well, before we run this, we have to create the database, and we also have to download the Java library for making the database work. So this service has dependencies that come from the Java world, and these are all set up by the setup.sh script. So if we run this, we'll run the setup for you. Now, the first command it launches is JPM install. JPM is short for the Jolie package manager. It uses the package.json format, which comes from Node.js. And if you go and look at package.json in this example, there is a subnode called Jolie, which contains Maven dependencies and the coordinates artifact on Maven. So this will tell JPM that we need to go fetch it and put it in the lib directory of our service. So now it's downloading and it appears here. So now I have the jar containing the driver to connect to the database. And then I'm launching setupdb.ol, which creates the tables for us, just by running a few statements. This is not a production example. I have used the feature of HyperSQL to use a CSV file as the backend, right? Normally, you would not have this line. I put this line just to show you the consequences of the demonstration that I'm going to run in a second. So if I launch this service, then I run the demo. I'm going to send a post message for user Alice. So I'm trying to create a user with this name, this email, and this karma. And I just get an empty reply. So it means it's been successful. And now I think if I go to the database and look at the CSV file, I'm seeing the result there. So this confirms that we have actually interacted with the service and it's put it in the database. Now I'm adding also Bob and Carol with different karma values. And now I'm just showing you that it works. So I'm getting information about Carol. We should see the same information we put, which we do. And then I try to list all the users with at least the karma level 4, which works. All right. So this is how you make a more realistic implementation of the user service. At this point, I should really mention that, I mean, it's not about Jolie per se, but you should be careful when you write services like this. These are just best practices. So the service I have implemented here is essentially stateless. It doesn't keep any state inside of the service. So it just interacts with the external database to keep track of the state. And this is a best practice because if in the future you need to replicate your microservice, you can do it. Or if you want to make the database scale up, you can create separate instances and all your microservices or all copies or replicas of this microservice will connect to the same thing. Another good thing to remember when you make microservices is that you should not share the database with anybody else. You should not make 2 microservices. So if you have another microservice interested in users, and we are going to see an example about that very soon, it should not access the database directly. Because if in the future you want to change how you have implemented the database, change the structure of the data inside of the database, then you will have a problem because there are other services that depend on you following that structure. Whenever you have 2 microservices interacting, they should always interact by means of their APIs or their access points, nothing else, essentially. Okay, so with that said, I'm going to make a slightly more involved architecture, which I have displayed here. I'm going to take a minute describing it. So this is a bit more how a microservice architecture looks in practice. I'm saying just a bit more because in a lot of examples that I've dealt with in industry, there are many more microservices, right? But this is the kind of thing that you need to get accustomed to, which is also why I find it very, very useful to draw the architectures of microservice systems. So the idea is the following. We have our user service using the database here on the right. I am not going to change a line of code of that, outside of the fact that I am using the binary protocol SODEP to access it. All right. Otherwise, it's going to be exactly the same. So we have our user service. And then I'm going to make a more interesting greeter service that replies to which you can just ask, give me the greeting for that user, like give me the greeting for user Alice. And now greeter will connect to the user's service and tell it, hey, I need the full name of Alice, like Alice Apple, because I need to produce a greeting for it. And this is what I meant before. We should not have greeter go in the database. Oops. We should not have greeter go in the database to figure out what the full name of username Alice is, corresponding to username Alice. We should ask the user service, because that data is handled by that microservice. Now, all these things, I want to keep them very efficient, so I'm using this binary protocol, SODEP. But at the end of the day, when you want users, sorry, we have a bit of a name abuse here because that's the name of the service. Let's say when you want your end users or people outside of your private secure network to access your services, you usually want them to use HTTP. So what I'm making here is an API gateway. This is a standard pattern in microservice programming. You make a gateway that exposes HTTP access points and then forward calls, performing the right protocol translations to your other microservices. So I'm going to build a gateway that accepts HTTP calls and then handles all the other communications with the other services to then reply to the client using the right format. All right, so let's launch the services. First, let me set up the user service using SODEP. Then I launch it. There it is. Then I'm going to go to the advanced greeter that I've been talking about, the one that can give greetings by username. It looks like this. It's very simple. It provides exactly the same interface. Well, not exactly the same interface, sorry. Now a request for greet takes a username, not directly the name that you want in the greeting. And we have a dependency towards service users. How do we use it? Well, when we get a greeting, we invoke operation get user at service users to get information about the user. And now I'm doing something even fancier. The greeting I'm producing, I put the happy face if karma is bigger than 3. Otherwise, I raise an eyebrow, right? Because you should behave a little better. And then I just make the hello message. Yes, if you're wondering if then else can be used both as a statement and as an expression in Jolie code. So this is an expression. All right, well, I have that, so I can launch it. It runs. I'm gonna make the gateway. So this piece here responsible for giving access to clients and doing all the protocol conversions and forward calls, get them back in the binary protocol, convert them again in HTTP and send them back. And this happens so often in microservices that we have native primitives for doing kind of stuff like that usually. So we have the gateway. The gateway has a dependency towards the greeter and towards users. And then we have an input port. This is where I store the information about how we are exposing a REST API and how it is converted towards our operation names, which is exactly what we had before. Now this information is at the gateway. But the really interesting part is this line here, aggregate, greeter, and users. So this line of code says that whenever we get a call from a client at this access point, this input port, and it is for an operation of either greeter or users, the call gets automatically forwarded, right? You don't need to do it manually, usually does it for you. So this line of code is essentially what implements this flow here from client to gateway to users and back. And the same for the greeter. The implementation is nothing because the gateway doesn't do anything else than forwarding calls. All right, this is just waiting for interruption from the console, essentially. So I can now run the gateway. Actually, let me put it down here because I want the big screen for the demonstration. So in the demonstration now, I'm going to show exactly the same commands we saw for users before. Now they go through the gateway. So this is just a demonstration that now, even though users is using a binary protocol, when we go through the gateway, everything works as it is supposed to. So we get information about Carol, which we get. We list all users with minimum karma 4, and we get them. And now I invoke the greeter. Notice that I'm using exactly the same address. So if I didn't actually make a gateway, this wouldn't work. So a feature of aggregating services or making a gateway is that now you can access multiple APIs at the same access point. So now I'm invoking at the same address another operation for getting the greeting for username Alice. I know that username Alice is associated to Alice Apple as a full name, so hopefully I get hello Alice Apple, which I do. Alice has good karma, apparently, so we get a happy face. Then I ask about Bob. Bob has good karma, apparently, so we get a happy face. Now I ask about Carol. Carol apparently has bad karma, so we get a raised eyebrow. Now, in my next command, I'm going to ask for a greeting for user David. And user David does not exist. It's not in the database. So I'm going to get an error. All right. It's pretty interesting to see how the error works. Well, it's interesting, but it's also very simple. So how does the error reach the client? If we look at the implementation of users, which is where, if we look at the implementation of the gateway, right? So in the gateway, I haven't written, sorry, wrong gateway. Yeah, in the gateway, I have not written anything about errors. So it doesn't come from there. The gateway just forwards the request. So it reaches the greeter. In the greeter, I haven't written, well, anything outside of, well, in the greeter, I have user not found. All right. So the greeter gets the user, but I'm not throwing the exception from there. So I go and look at users. And this is where I actually throw the user not found exception. All right. We call this automatic fault propagation. Essentially, if you are in the middle of processing a response, but you have dependencies, if one of your dependencies throws a fault, then it gets automatically propagated to whoever called you until somebody handles the exception or the fault. And that's how it works. So not only messages are forwarded, well, these are also messages, but also the faulty messages are forwarded without you having to do anything. All right. Now, the last example I'm going to show is a slightly more interesting gateway. So let's see. We have exactly the same architecture, but now I call it a gateway with authentication. I'm applying another pattern from microservice programming called the API key pattern. By the way, there exists a website which is very good, which I show in the README of the entire repository, called Microservice API Patterns. You can go in there and you will find a description of a lot of very well used API patterns for doing microservices. But anyway, the architecture I'm doing now is essentially the same structure as before, but you know, since we can create users now, so we can modify the database through the gateway, I don't like the fact that people can do it without any sort of authorization. Like anybody from the internet can arrive and say, oh, let's add this user to the database. I would like some kind of authentication on top of it. And it is a very common use of gateways to add authentication because you want to keep the services that you are protecting, in a sense, simple, but you also want to, as I said, protect them from the external network. All right, so how does the gateway look like? We have exactly the same structure as before, but I have added this. So when I aggregate users, I'm using what we call an interface extender. Imagine it like this. Before, when we were invoking operation create user, we were just sending data about the user. Now I would also like a little token, which is an authorization token. Like you can imagine it like, as if it were a password. It's called an API key in this case, because it is not your actual password, just a security token that you're using for this purpose. But I want to add this security token to all messages for creating a user. And the way you do this is by using these interface extenders, which you define like this. So you write interface extender, authorization extender in this case, and we specify that when we get a call for create user, we want to add these features. So the input data should also have the API key, and it might throw a new fault called unauthorized. I don't touch the rest. The rest is exactly as before. And then I use it in the gateway. I create what I call a courier process. So this is a piece of code that runs when you forward messages. So it essentially means at this access point, when you get a call for create user, you check if the API key is bearer 1, 2, 3. I've just chosen a constant in this case. Here is where you would actually go and check in a more structured way. If it is not that, we throw the unauthorized fault. Otherwise, we forward the message. A forward is a primitive usually. So when you are in this courier code in between the gateway and another service and the client, you have access to this primitive. This primitive does something very important. It removes all the new data that you have extended the API with. So the API key is not expected by the user service because it's only expected by the gateway. So forward removes that piece of data for you, and the user service will never see it. All right, now without restarting my other services, I'm just gonna close my previous gateway and start my new gateway with authentication. And hopefully the demo runs in the sense that I use my new gateway to try and create user David. And this doesn't work because I forgot to put the API key. So now I try again by adding the authorization header. It's a pretty standard header in HTTP, using the API key that I need. And I try again, and now it works. So now I can create David. Notice that I didn't restart the other services because this change to the gateway is completely orthogonal to them. And now I try to get user David, and I get the data. And I try to get a greeting for David, and I get the greeting for David. All right. So this brings us to the end of the presentation. What have we seen? We have seen a bit how it is to program microservices with Jolie and how you can reflect some of the key concepts in microservice programming, in particular access points, the implementation of your services, the separation between how you access services and how the operations of the services are implemented, and how you can play around refactor architectures in a microservice system supported by the language, because you only go and change things in a non-intrusive way. You usually keep the implementation free from these changes. And with this, I think I can give back the word to Jacopo. And if anybody has questions, they would be very welcome to ask them.
Thank you, Fabrizio, for the nice presentation and demo.
Thank you.
And I would say that differently from the former webinars, I could stop the recording now so that people even in class is free to raise questions without getting recorded. And maybe this is easier for everybody. So,
usually the questions are much better than the presentation.
Thank you. Thank you, Fabrizio. Thank you all for attending. And here I stop.